Okay, so today's lesson is on regular polygons, and that area formula for regular polygons is A equals 1/2 A times P. We have A, which stands for the apothem, and it is pronounced apothem, which is the length from the center of the polygon perpendicular to the side. So that would be the 15 side here on my first example. It goes from the center perpendicular to the side. P stands for perimeter, which means we're going to be adding up all the sides. Now, this formula is actually derived from the area of a triangle formula, which is 1/2 the base times height. So if I redraw my pentagon here, and I have the center, here's the apothem. And then if I draw my radii from the center to the vertex, that gives me a triangle. So here's my base, and that's going to be the side length for the perimeter. Here's the height, which would be the apothem in my regular polygon, and I would find the area of this triangle. Well, that same area repeats when I connect all of the radii to the vertices. So once I find this area, so instead of finding the base, that's why I find the perimeter, because it's going to be the same base all the way around. Regular means all the sides are equal and all the angles are equal. So by taking the perimeter instead of the base, then I get all 5 triangles at once, or however many sides I have. That apothem represents the height, and because they're triangles, we're still taking half of it. So now if I go to example 1, first thing I want to do is find the perimeter, because that's one of the mistakes people make when they work the area of a regular polygon formula, is they tend to put the side length in instead of the perimeter. So here's the perimeter. I've got a side length of 12, and I have 5 sides. 1, 2, 3, 4, 5. So when it's regular, they're all 12. So I have 12 5 times. So that gives me a perimeter of 60, and that'll be units. Then for my area, I'm going to take 1/2. The apothem is 15, and my perimeter is 60. And when I multiply all of that together, I get 450, and it's area, so it's going to be units squared. And that's going to be my area. Okay, when I get to example 2, I'm going to go with my perimeter first. So I'm going to have my perimeter. I have a side length of 10, and I have 3 sides. That means I have a perimeter of 30. So when I find my area, I'm going to have 1/2 times the apothem, which is 2 square root of 3 over 3, times 30, which is my perimeter. Now, I see 3 goes into 30, so I'm going to simplify that, and that gives me 10. And then I see half of 10 is going to be 5. So that leaves me with 2 square root of 3 times 5, which comes out to 10 square root of 3. And that's going to be units squared. Now, I don't specify on your homework or your preview what form of the area I want to see. So you can leave it in exact form, which is 10 square root of 3 squared, or you can type it into the calculator and get 17.32 units squared. So that would be the decimal representation of the area. In example 3, I have a different situation here. I have a radius. This 6 does not represent my apothem. So I need to create my apothem by drawing my center perpendicular to the side. And I don't know what that is yet. Based on what I know about an equilateral triangle, I can tell you that the sides, the measure of the angles are 60 degrees here. That radius is going to split that angle in half. So that's going to be a 30-degree angle. So now that I know that this is 30 degrees, I know this one here at the center is 60 degrees. And that means I have a 30, 60, 90 triangle. We learned 30, 60, 90 triangles. Those are part of our special right triangles. We used a graphic organizer. So here's my 30, 60, 90. I know that pattern is x square root of 3, and 2x. And that radius 6 is across my 90-degree angle. So I'm going to put 6 underneath the 90 because it's across from that 90-degree angle. And now I'm going to use these two boxes here to write an equation. 2x is going to equal 6. That's going to help me find out what my side lengths are for both the 30-degree side and the 60-degree side. So when I divide by 2, x is going to equal 3. And the 60-degree side is going to be 3 square root of 3. And I need both those sides because the 30-degree side is my apothem. That's my 3. My side length, or actually part of my side length, is 3 square root of 3. Okay, and it's only part. It's only halfway. So if I want the entire length, I have to double it. So that's going to be 6 square root of 3. So if I find my perimeter has got a side length of 6 square root of 3. I have 3 sides. That's going to give me 18 square root of 3 for my perimeter. And my area is now going to be 1/2 the apothem, which we found to be 3, times that perimeter, 18 square root of 3. And if I multiply those together, I get 27 square root of 3. That would be the exact answer, units squared. And if I type it in my calculator, I get 46.77 units squared. So I would accept either one of these answers because I don't specify whether I want the exact answer or the decimal representation. Moving on to example 4, it's going to be very similar to example 3 because I'm given a radius. So let me draw in my apothem. And here's my side length. And I know that the measure of an angle in a hexagon from previous lessons is going to be 120 degrees, which means that this radius splits that and makes that one 60, which makes the one by the center 30. So again, I have a 30, 60, 90 triangle. You know, my pattern is x square root of 3, and 2x because we had previously learned that. Those are available in your notes and on posters on the wall. And my 10 is across that 90-degree angle, so 10 is going to go underneath my 90. And just like before, I'm going to use these two to write an equation to find x in the other two boxes. So that means that 2x is equal to 10. Divide by 2. And my x is going to equal 5. That means x here is 5. And that means x square root of 3 is 5 square root of 3. This time my apothem is across the 60. So my apothem is the 5 square root of 3 piece. And the 30 is 5. So that piece of my side is 10. That means the entire, that piece is 5. So that means the entire length is 10. Now if I find my perimeter has a side length of 10 and I have 6 sides. So I have a perimeter of 60. My area is going to be 1/2 the apothem we found to be 5 square root of 3 times 60. That's going to come out to 150 square root of 3 units squared. And decimal wise, when I type that into my calculator, I get 259.81 units squared. And I would take either one of these answers. Okay, I'm going to clear my board and move it up. Okay, now we have example 5. We have a similar situation to 3 and 4, but it's a little bit different. I have a radius of 8. In a regular pentagon, the measure of my angle is 108 degrees. Let me draw in my apothem. That's my apothem here. And as we discussed, that radius splits that angle in half. So half of 108 is 54 degrees. Now that's not a special right triangle as in the case of the example 3 and example 4. So here I'm going to need to use trigonometry. And we've used that before. So if I label my sides, I have 54 down here. My apothem is going to be my opposite side. My side length is going to be my adjacent side. And my 8 is going to represent my hypotenuse. So if I need both my opposite and adjacent side, because my opposite side is my apothem and my adjacent side is my side length, then I need to use trig to find those missing sides. So we have SOHCAHTOA, and that was our little mnemonic device that helped us remember our trig functions. And I need opposite and hypotenuse, and that means I'm going to be using a sine function. So sine of 54 degrees is equal to opposite over 8. And in this situation, I'm going to cross multiply. And when I type that into my calculator, I get 6.47 is my opposite side. Make sure your calculator is in degree mode. Now to find my adjacent side, I need adjacent and hypotenuse. And that's going to be my cosine function. So I'm going to have cosine of 54 degrees equals my adjacent side over 8. It's similar to the sine one. That means I need to cross multiply. And I get 4.70 is equal to my adjacent side. Now from here to here is 4.7, which means my entire side length is going to be 9.4. So when I find my perimeter, I'm going to have 9.4. There's 5 sides. That's going to give me a perimeter of 47. For my area, it's 1/2. My apothem, that's where the opposite side comes in. That's 6.47 times the 47 for my perimeter. And when I multiply those together, I get 152.045 units squared. And that's my area for a regular polygon. So you are going to have to use trig on some occasions, and you may have to use Pythagorean, the special right triangles, like example 3 and 4, because you'll notice that that'll happen with the equilateral triangle and the regular hexagon. Those will use special right triangles. The other one that uses special right triangles is the square, and the square would use the 45, 45, 90. And we're done with regular polygons.